Hey everybody, thanks so many people to come on. Pretty surprised. It's very much an informal, practical session here. So, you know, various people are going to come and actually fiddle with stuff. That's going to be absolutely fine. That's pretty much what we're looking at. What I want to do is look at some cameras and the setup and what it actually looks like up and running. What what the software looks like on the screen. How different cameras will give you different frame rates, and what some of the stuff we keep babbling about actually looks like. Obviously, you can't actually image planets. In theory, this thing's supposed to be able to focus down to about 20 feet. So I maybe I'll just point at a picture of Jupiter on the back wall there. Never know. It's worth a go. So that'd be a challenge for everybody to try and find Jupiter in the Planetary camera over there. 2 centimetre big size Jupiter on the back wall there, which is not so different to looking at the real Jupiter. It might be a bit big, but that's probably a good thing. So, yeah. So, what is the basic setup for this? Is equatorial mount really helps because it's just going to track the planet for. It's not exactly the planet moves slightly in relation to the stars, but it's not really a factor for your imaging. Your mount's reasonably well set up and reasonably polar aligned. Then you're going to track Jupiter for as long as you want, with very, very minor corrections. I can easily go on an hour when it's really, everything's working really well. I've gone an hour without really touching, and Jupiter's still well in frame. So these things don't move very much in relation to the sky, and are big and bright. So, and it's not like deep sky imaging where you're using guiding to try and keep it within a pixel. You're taking a video, it doesn't matter if it moves by a few pixels over the course of 2-minute videos. So the equatorial mount's your friend really. If you've got that said, if you've got a decent alt-azimuth mount that's tracking, again, I mean, I haven't much personal experience with alt-az, but anyone who has, I don't know how long you're able to video without rotation, without the rotation in the sky being a serious issue. Has anyone done any planetary imaging with an alt-az with a fork mount?
Rotation as in like a single video?
Yeah, in a 2-minute video, do you get any noticeable rotation on the disc? I wouldn't have thought so.
It's like when you're
Before it makes any difference. Okay, so for single planetary imaging, it really doesn't matter if you're using a alt-az mount, which I know quite a few people have got LX200 type things, where you don't need to put it on a wedge. It's going to track the planet perfectly fine, and you're going to be able to take videos and you're going to do exactly like they do on the equatorial mount. The equatorial mount makes it easy because it will track all night, but and if you're trying to do time-lapse videos, then you've got more work to do if you use an alt-az mount, because every frame of your time-lapse video, the planet's going to be doing that. Whereas with one of these, the planet's going to be perfectly steady. So any old equatorial mount. I was doing planetary imaging on an old EQ3 Pro that I got for $500, and that worked absolutely fine. Once I went to a bigger mount, I had a bit less work to do keeping the planet in the frame as well. So that's pretty easy. So any old thing. This is just the Society's loaner mount for people. So if you want to give it a go, then talk to Steve about this kind of stuff. And you can actually rent these kind of equipment from the Society. This is a classic telescope for things like planetary imaging. Again, you can pick these up second hand. People tend to actually have some slightly optimistic views of what they're worth, I think, when they sell them, because they see it as an old classic. But you can pick up, if you watch Trade Me carefully, you can pick up an 18-inch Schmidt Casson grain for not that much money, and they are ideal scopes for planetary because they're long and not very heavy. And this, I pick it up in one hand, no problem. And you never have a problem with getting in focus. Anyone who's used your various Newtonian telescopes especially, you're fighting all the time to actually get the camera, the imaging chain, so you can actually get to the focus. That's never an issue with these things. You've got backwards and forwards for Africa. Fantastic. Wouldn't normally use a diagonal. This happens to be on here, so I've just plugged it in. But you'd normally be straight into a read at the back. That's just sort of basic tube. If you're imaging planets and you're wanting to get in and get good details, then a decent Barlow lens is pretty much essential. Even on this has got a 2-meter focal length. There's a 20 centimeter f10. You put one of these on, you're going to 4-meter focal length. That's pretty impressive, and it will handle it. No problem at all imaging at that. All the images I've got of Jupiter that you see of mine were all done at f20 with that barlow, which is just came in a kit of lenses, just a Celestron 2-inch barlow. On that thing, produces pretty good images. Collimation is completely critical. If the collimation is bad, your images are going to be really poor. You do have to make sure you spend the time to keep your telescope collimation right. So cameras, again, can be obtained pretty damn cheaply these days, especially second-hand. Somebody picked up one of these from one of our members for for $150 or something the other week, so that was a pretty good deal. We've got here, this is the one Astron Stealth, or it pretty much, I think, stopped selling this one. They're moving on to the three USB 3 ones. This is the USB 2 QHY5P colour, so this is the high resolution colour camera. Again, all my planetary images are taken with this camera. Pretty easy to use. Software can be a bit of the drivers can be a bit dodgy, but it plugs into SharpCap or FireCapture, which are everybody's go-to packages, I think. There's what looks like an identical camera here, which is one of them they brought along finally. This is the L version, which is a lower resolution version of the same camera. That's the colour one. Yeah. The pixels are bigger because it's much lower resolution. But the advantage of that is it fits very well with some telescopes better, and your frame rates and stuff are much higher because there's much less data to download. You end up with a lower resolution image, but it's a trade-off. But you get great range or something like that. Again, they're both been replaced by a USB 3 version, which gives you even better frame rates and stuff. Liam's also brought along a much better camera, which is the ASI 224. Yeah. This is the USB 3, and it's the fancy cable. I'm not sure what exactly frame rate you'll get. We'll plug it in and have a look because I installed the driver for this before it came out. We'll see the difference. And this is a very nice camera, a little more expensive, I think, than the QHY, is it?
Roughly about the same, but those
Okay,
a year's difference.
But I think it might be a better deal as it stands at the moment,
Yeah.
because they've got an eye sensor and this with the blaze along. Most of the internet seems to swear by them anyway, as it stands down. So I'm not sure what that is. That's the nose piece for that. That's the nose piece for that. Okay. So we've got it set up like this. We get it approximately aligned. We get it pointed in the general direction of Jupiter. Can't see anything in the planetary camera. I'd say it's people's biggest frustration with planetary imaging is trying to actually get the damned planet into what is a very small image though. The chips on these are not large. You're working at long focal lengths. You're imaging a very tiny bit of sky. You're looking through your finder scope, you're going, it's right in the middle. I can't see anything on the camera. And you start thinking there's something wrong with the camera, etc. So a few tips on that before I start fiddling around with cameras. Probably the biggest tip for that is get the damn finder scope aligned. Point the telescope at something, do it in the daytime before you start. Point the telescope at something a long way away, top of a telegraph post or something, and then get your camera on there. Just swing around until you find something, get on your finder scope and adjust it till it's precisely in the middle. So whatever's in the middle of the finder scope is in the middle of your camera. At that point you've got a pretty fair chance of finding, especially Jupiter, which is really bright. You'll have a pretty fair chance of finding it. Another tip, if you're using a Scarwatcher mount, I'm not sure about the software for the Electron, but it's probably got the same thing. Once you're in there and you've got EQ mod or something running, there's a little spiral search button, which will basically move the mount in a square, starting where you are and going outwards in a big spiral, and eventually it's going to find the planet. And as you just watch the screen while you do it, and eventually you'll see the planet flash past and you'll stop and do it again, and you'll home in on the planet. It can be frustrating. A lot of people give up without ever seeing the planet in their telescope, I know. But once you've got through that, practice that, and start to get the alignment well on your finder scope, you'll get it every night. The other problem is focusing. And you've got to find the planet and you've got to focus. The big trick is get the telescope approximately in focus before you start. So again, focus on a distant object in the day. Get it focused on a very distant object and it's pretty close to the focus of the planet. So your planet's going to be a little disk. Turn up the brightness on the exposure time and go out there and hunt it. So if I kill the slideshow, the camera is plugged in, it's just a USB cable. sharp captures. I don't know anything about fire capture. I've got fire capture installed. If anyone here's a wonderful expert in that, they might want to run through a quick demo of how it looks and works, because it's no good asking me. I've always found sharp cap to be quite fine for the purposes I'm using it for. So we go in here and sharp cap. It knows about my QHY camera because I've already installed the QHY drive and the camera plugged in. And there we go. I've got it set to a fairly large area. It's not quite the full frame. And I've got it set to a, check this off. Here. I'm sure at some point you expect to see some. You see down at the bottom here, you look at something like sharp cap, what are you seeing? You're seeing preview image. You're seeing a thing here that shows you how much of the full frame you're using. So I'm using most of it, and square. You'll see all the format settings. We'll run through some of those in a minute. You'll see down here, your bit you spend half the time looking at. What's the frame rate looking like? It's currently frame rate 5 frames a second, which with these big, almost the entire camera, you wouldn't image like that. But yeah, it's enough to actually find things, etc. But the exposure is very low, 8 milliseconds, and not very much gain, so that wouldn't be any good for actual imaging. But when you're trying to find things, you're running the exposure up here in 100 milliseconds plus, running the gain up a fair way. Is there something in the way here? Or it's just dark in here? But it's dark in here. I'll point this over there where it's a bit lighter and I see something. Okay, who's the expert on one of these iPod settings? Can we set the speed?
I'm just on the top.
Press 9 for maximum speed, press 1 for minimum speed, or something in between.
Oh, that's better. Okay. Over there, looks like. Something a bit lighter. It's pretty dark there, isn't it? I'm not seeing anything, any lightness on that screen at all.
No.
That's a bit strange, isn't it?
Check the cameras plugged in.
Yeah, camera's plugged in, and well, I've got 5 frames a second, so we've got definitely got the camera plugged in there. Question of why we're not seeing any light there, I don't know. Can anyone think of a reason? It is a practical. No, that's definitely not picking up anything, is it? It's just a low strength. So if anyone's got any, so this is a practical session. So who's got good ideas as to why we're not seeing anything at all in terms of light? Camera behaviour stuff. Can you put your light on again? Get a torch. Not seeing it downstairs. Okay, well let's try the other camera.
I'm not plugged in.
No, it is plugged in. It's flashing its light, but that's okay. We'll come here and you set things up in this kind of environment. That always happens. Frame rate's gone to the dogs anyway. Always happens when you're demoing anything, doesn't it? Disastrously wrong.
Maybe I'm not doing anything wrong yet, then all because it's the same thing I did. Oh, here we go. You're doing something now.
Is it?
No, it keeps dying, keeps going up and down and dying, which is absolutely marvellous. I've no idea what it wasn't happening last night when I tested it. Can't say I'm surprised. Let's just go out and back in again, try it in a different USB port in case it's something about that. So, this is the kind of nonsense you end up dealing with, of course, until you get your equipment stabilised. I have some reservations about some of the QHY cameras precisely because the drivers are sometimes less than perfect. And this kind of thing can happen. We'll try the ASI one. I wanted to throw a bit of a comparison of how the different cameras look in here, because I know what you see here varies depending on what camera you're using. Let's see what we've got. Well, that's just about figures. That just about figures, doesn't it? Okay, well, let's try. Oh, there we go, 10 frames a second. There we go, we're actually, okay, it's woken up. So, we're actually seeing something. Not much, but we're seeing something. We actually think it's looking at over there. So that's putting the black roof, which probably doesn't help. Yeah,
Oh, there we go. Yeah,
so we're awake.
the seeing stuff.
So this is actually Ah, there we go.
Oh.
Not really so very different to what we would do an imaging setup, which is nice. I assume they look like some big dust bunnies on there, don't they?
Yep.
Which is what we're sort of carrying everything around. So this is what you'd be doing with a daytime setup, is getting in here and finding approximately where the focus is, which will be totally different to a visual setting. We should probably find that we're going to start seeing something over there, over in the corner there. Has that got a cap on yet? How many times have we all done that? Well, for me, we've all done it. I'm going to cap on this end as well. Now, aren't they? All right.
Too many.
Funny.
Too many cats.
So, no, I'm not seeing much of any detail or anything, but then I suppose it's not exactly an ideal target. I didn't really expect it to be. You can see a sort of, you can see that we're imaging, you've got a frame rate, etc. You've got lovely dust all over the sensor, or over the diagonal or something. Okay, so,
Might reach focus if you remove the diagonal.
pardon?
You might reach focus if you remove the diagonal.
Sure.
That's true, but I don't think there's a background here. There's probably one in there for it. If someone wants to have a look and see if there's a visual, see if there's an eyepiece holder back in there. So yeah, so this is running at so I'll set this up pretty much how you'd be looking at for imaging Jupiter. You'd be looking at something like 25 frames a second, and getting about 10 seconds. The Jupiter's pretty bright, because compared to that all over there, where you've seen that, you'd be seeing at this kind of setting, you'd be seeing a very nice clear Jupiter. So, and here I'm looking at, like I say, 20 frames a second. This is not representative of how you get it. If you're really imaging like this, at 800 by 600, you probably on this camera see about 40, 45 frames a second, which is pretty good if you're running at 25 milliseconds. That's about all you can actually do. 25 milliseconds times 40 is a second. You can't really genuinely get any faster than that, because with that kind of exposure time, because you run out of seconds to do it. You only fit so many frames at a time. From my experience, this is a huge, certainly for the QH5 cameras, we have much testing with this. If you want good images, you get the gain down as low as you can. With Jupiter, you can probably get the gain, you can often get the gain down to about 8, maybe, on Jupiter, and the exposure to like 25 milliseconds. That seems to be a bit of a sweet spot. Don't be tempted by anything that's telling you, certainly for the QHY cameras, don't be tempted by anything telling you to raise the gain higher and lower the exposure time. You just get crazy, it's too much noise. You can only remove so much of the stack. If you can't see on Jupiter, let me actually show you something here.
Is gain kind of equivalent to ISO?
It is very similar. Yeah.
Gain is actually the right thing to refer to in a digital sense.
ISO is a gain is in order to be able to talk photographers.
So gain of 8 is a...
The actual number is totally dependent on the camera and the manufacturer. It doesn't really, there's no way, you can't say, oh, you can look at this camera and go, I'm running a gain of 8. It doesn't tell you anything about what the gain will be on an A5 camera.
Same thing goes for non-exposure.
Yeah.
So then you do as well, you compare ISO 1600 from a Nikon to a Canon, totally different thing.
Right.
Yeah. So it's just their notation telling you, on the scale of your camera, it's telling you what's happening. But it's not, they're not comparable things between cameras. So, a lot of people, the other tempting thing with all of this, I came to astrophotography assuming this, that you're always wanting to image at the lowest possible gain, the lowest possible ISO, because it's just faking it in the camera by boosting it up. It doesn't work like that. There is a sweet spot. For some cameras with linear sensors, there isn't even a sweet spot. You can push the gain as high as you like. Canon cameras, you can't. So there's a sweet spot around 1600 or something like that. Lower than that, you're not getting the best result. So because the gain, the way the various stages of the electronics work, is that some things happen before some other things. So gain happens before some of the noise is introduced. So if you, it's not like brightening in Photoshop. You're not just adding noise. You can get something for nothing almost in that sense. So, okay, cool. Yeah, you don't fancy swapping that out, do you? I just yeah. Stop talking, you do the thing where I stop talking, fill the tail. I feel embarrassed doing that.
Very good performance.
So, what are you going to see on I'll play one of these videos. Nothing racing, I promise. Unless this is your thing. Okay, this is a planetary capture that I used to make an image that I posted on a group which you may have seen with Europa, yeah, right next to the planet. So why does it look like that? All speckly and stuff. That's because I've taken this in raw 8, which means it is not debated. So the red, green, blue aren't being translated back into red, green, and blue to the image. So you're seeing this pattern all over it. When you load it into your stacking software, it debated it and you see the proper image. So if I take the same image, and you can see on here, it looks better on the real screen than on here, but you can see the cloud bands, you can see the spot. On some of these images, you can clearly see more detail than that. So it's if you can't see that, that's kind of what you expect to be able to see. Is a bit of a look at. There you go, a bit better on that one maybe. You know, you need to see some detail on your image. This is what you're seeing in colour on your screen while you're capturing. So if I open one of those in Auto Stacker instead.
That's not cropped or anything.